Welcome to your deep dive. Today we're diving deep into the world of inflatable space habitats.
Oh, inflatable, you say?
You heard right. We're talking about a future where instead of those big clunky space stations, we've got these, well,
Flexible modules.
exactly. We're going to look at everything from those early experiments way back in the 60s all the way to the companies that are pushing the limits today and
How they're making it a reality.
yeah. And to help us make sense of it all, we've got expert speaker ready to walk us through, well, everything.
I'm excited to dig in.
So before we launch ourselves into the future of space living, maybe we should rewind a bit. This whole inflatable thing in space, it's not exactly a new idea, huh?
You know, it's really interesting how some of the most, I'd say, cutting-edge tech we see today actually has roots in these really simple ideas.
Okay, I'm intrigued.
Take, for instance, Project Echo back in the 1960s.
Oh, those big, shiny satellite things, kind of like giant disco balls up in space. I vaguely remember seeing pictures.
Exactly. Project Echo used huge mylar balloons, like massive. Echo 1 was 100 feet across, and then Echo 2, get this, was 135 feet. They used them to bounce microwave signals around the Earth.
Wow, 100 feet, that's like longer than a blue whale.
It's massive. And, you know, they weren't habitats or anything, but they proved a point that inflatable structures, they could actually work out there in the harshness of space.
That's pretty mind-blowing when you think about it.
Yeah.
But the U.S. wasn't the only one playing around with this inflatable tech back then, right?
Oh, not at all. The Soviets, they were right there too. In fact, you know that very first spacewalk back in 1965? Cosmonaut Alexei Leonov, he used an inflatable airlock on his Voskhod 2 spacecraft.
An inflatable airlock. Now, that's putting a lot of faith in some pretty new technology, especially for something so important.
Talk about a tense moment. Well, it involved a few more hiccups than planned.
Oh, no, what happened?
Well, Leonov's spacesuit, it basically stiffened up in the vacuum of space, made it almost impossible to get back inside the spacecraft. Yeah, to squeeze back in, he actually had to, manually bleed off some of the pressure from his suit.
No way. Talk about a high-stakes situation.
Right. But hey, it worked. And it shows how long we've been tinkering with inflatable structures out in space.
We've come a long way since then, thankfully. But speaking of pushing boundaries, Bigelow Aerospace, they were really the ones who took this inflatable habitat idea and just ran with it, didn't they?
Absolutely. Bigelow, they were really leading the pack there for a while. They launched their own prototype modules, Genesis 1 and 2, back in 2006 and 2007.
And those were both inflatable.
Full-on inflatable modules. And get this, they're still orbiting Earth today.
Still up there after all these years. That's amazing. Weren't they also involved with the ISS?
They were. They even got one of their modules, Beam, hooked right up to the International Space Station. It's still there now.
Wow, that's a pretty big deal.
It was a huge step. Sadly, Bigelow Aerospace, they shut their doors back in 2020.
Oh, that's right. I remember hearing about that. What happened?
It's a tough business, space exploration, but even though they closed, their legacy, it's huge. They really paved the way for a lot of the companies that are picking up the torch now.
So who are these companies? Who's carrying the inflatable torch, so to speak?
Well, there's Max Space, for one. They're setting their sights on more than just Earth orbit, think Moon, even Mars, with these inflatable habitats.
Wow, Mars. That's ambitious. Who else is in the game?
You've also got Sierra Space. They're developing something called LIFE, the Large Integrated Flexible Environment.
Okay, catchy name. And these are both companies focusing on inflatable habitats.
Exactly. They're both really pushing the boundaries of what these inflatable habitats can be.
It's exciting stuff, but let's get down to the nuts and bolts here. We're talking about creating living spaces in space, which is
the ultimate challenge.
right. So what are these things even made of?
That is the million-dollar question, because you're talking about surviving some seriously harsh conditions. One of the key materials, I guess you could say the star of the show, is Vectran.
Vectran. Okay, gotta be honest, that doesn't ring any bells. What is it?
It's pretty wild stuff. Imagine a fabric, but way stronger than Kevlar. It can handle crazy temperatures, radiation, even those tiny, super fast micrometeoroids that are zipping around out there.
Okay, so like the ultimate space-age fabric.
Exactly.
So the next time I need an indestructible picnic blanket for a zero-gravity lunch, I'll know what to ask for.
Well, maybe not a picnic blanket, but you get the idea. Vectran is the real deal. It's actually what they used in those Bigelow prototypes, Genesis 1 and 2. It's that strong.
Right, Vectran, got it. But hold on, we're really talking about building, like, full-blown space stations out of what is essentially fabric, even if it is super high-tech fabric, that seems incredibly ambitious.
Ambitious, yes. But that's exactly where this is all heading. Max Space, for instance. Their goal is to build these inflatable habitats that are absolutely massive. We're talking multiple football fields big.
Hold on. Multiple football fields. You're kidding.
Nope. That's the scale they're aiming for. Imagine the possibilities, the sheer amount of living space, working space that could provide.
That's unbelievable. But how is that even possible?
It all boils down to the strength-to-weight ratio of these new materials. Plus, remember, these things launch in a compact form, all folded up, and then they get inflated once they're safely out in space.
So no more trying to wrangle heavy building materials in zero gravity. Smart.
Exactly. It's a game changer for space construction.
It really does sound like the way of the future.
And speaking of exceeding expectations, you know who's been putting these inflatable structures through the ringer?
Ooh.
Lockheed Martin. They've been running all sorts of tests, like these pressure tests, pushing the inflatable structures way past what they'd normally experience in space.
And how are they holding up?
They're exceeding expectations, proving just how strong this tech really is.
Okay, color me impressed. But before we get too carried away with all the positives, let's be real for a second. There've got to be some downsides to this whole inflatable approach. It can't be all smooth sailing, right?
Right.
It can't all be easy. What are some of those challenges? What are we up against with these inflatable habitats?
Well, like with anything new, there are always going to be bumps in the road. One of the big ones is protection. When you're out in space, you've got those micrometeoroids flying around at crazy speeds.
Like those tiny space bullets we talked about earlier.
Exactly. And even a tiny one of those could really mess up an inflatable structure, if it hit in the wrong spot.
That makes sense.
So companies are coming up with these really sophisticated shielding systems, specifically for these inflatable habitats. Like Max Space, they're working on a special debris shield, kind of like a bulletproof vest for these structures.
A bulletproof vest, that makes sense. But what about us? What about people actually living in these things? Living in, well, basically a giant balloon in space. It's got to have its own unique set of challenges.
You're hitting on a really important point. Before we all pack our bags for a one-way trip, scientists are looking into things like, well, what does long-term exposure to low gravity do to the human body? What about the psychological effects of living in these confined spaces? We've got to figure that out.
Right, like those biodome experiments they did here on Earth, but in space.
Exactly. Figuring out how to create a completely closed-loop system to support human life, it's crucial if we're talking about missions that last longer than, a quick trip to the ISS. We're talking about breathable air, recycling water, dealing with waste, and doing it all without using too much energy.
Sounds complicated.
It's a huge challenge.
It really does. But maybe let's shift gears for a second. We've been talking a lot about the how of all of this, but what about the why? What's so great about this inflatable approach? Why not just, stick with those classic rigid space station designs we're used to?
Well, that's where things get really interesting. Because it's not just about building bigger things in space, it's about building smarter.
Okay, I like the sound of that.
See, traditional space structures, those rigid ones, they're not very flexible once they're up there. But with inflatable modules, adaptability, that's baked in from the start.
Adaptability. Can you give me an example? What does that look like?
Sure. So picture landing on the moon. It's not exactly a smooth surface, right? Lots of craters and bumps. But with inflatable modules, you could create a habitat that actually molds to the lunar landscape.
Oh, interesting.
Yeah. You get a more stable base, and it can adapt to the environment. And then you can connect different modules, like linking them together to make your habitat bigger whenever you want.
Like space Legos, but for lunar bases.
Exactly. So instead of just a few astronauts huddled in a tiny lander, we're talking about creating these sprawling, adaptable lunar settlements, all thanks to inflatable tech.
That's pretty wild. But I have to ask, what about connecting these modules up in space? In a vacuum? That can't be easy.
It's definitely a challenge and a major focus for engineers right now. Think about it. You have to create an airtight seal between two modules while floating in space, zero room for error.
Sounds pretty stressful.
It takes a lot of careful planning and engineering.
Yeah.
It's not just the materials. It's also about figuring out the best systems and processes to put these things together in such an extreme environment.
Right. Everything has to work perfectly.
Absolutely.
So we've covered the practicalities, the strength, all that. But has anyone gone beyond just thinking about basic habitats? Like, is anyone thinking about making these inflatable structures a little more architecturally interesting?
That's a great question, and it's something I actually talked with a space architect about recently. And yeah, they're definitely thinking along those lines. They believe inflatable structures could lead to some really cool, innovative designs in space.
Okay, now you've got me curious. What kind of designs are we talking about? Give me some examples.
Okay, so one concept they were exploring was this idea of building these huge transparent domes, but made from these super strong, reinforced, inflatable materials. And these wouldn't just be functional, they would give astronauts these incredible panoramic views of space, all while keeping them safe and pressurized inside.
It's like something straight out of a movie. Instead of force fields, we've got inflatable domes.
Right. And it's not just about the views. They could use these domes to grow plants. So astronauts could have fresh food and, a little bit of earth out there in the vastness of space.
A space garden with a view. Sign me up.
Exactly. And that's just the beginning. Imagine zero-gravity sports arenas, underwater research labs, built inside inflatable structures and then submerged in, like lunar ice, or even get this inflatable concert halls.
Okay, now you're messing with me.
Yeah.
Inflatable concert halls. That's straight out of the Jetsons.
I'm serious. Think about it. No gravity to worry about. You could create these amazing acoustic spaces for musical performances that would be unlike anything we could ever do here on Earth.
Okay, you've got a point there. I'll admit that does sound pretty amazing. But let's pump the brakes on the futuristic space symphony for a minute. What are, the biggest hurdles we still need to clear before we start handing out concert tickets?
One word: durability. We've talked about shielding against those micrometeoroids, but you also have to think about constant radiation from the sun, and then you've got these crazy temperature swings in space. It can go from super hot to freezing cold incredibly fast.
So how do you design something that can stand up to all of that?
Well, that's what scientists and engineers are working on right now, new materials that can handle the absolute worst that space can throw at them. Stronger, more tear-resistant, better temperature regulation, all while staying lightweight and flexible enough to be, inflatable.
It's a tough job, for sure, but it's not all about those futuristic materials.
Right. One of the most important things, maybe the most important, is the life support system.
Yeah, of course. You could just open a window to get some fresh air when you're in space.
You got that right. We need systems that can constantly make oxygen, clean and reuse water, and deal with waste, all within this closed-loop system.
So we're essentially talking about making miniature Earths where everything gets recycled and reused.
Pretty much. And it's not just about having enough oxygen, You got to maintain the right air pressure and filter out the carbon dioxide. These systems are super complex. They need to be designed really carefully with backups for everything to keep everyone safe.
It's amazing that we're talking about all of this as something that's actually doable in the near future.
It is incredible.
But let's be real. Most of us aren't astronauts or billionaires jetting off into the cosmos. So what does all of this mean for the average person? Are we going to be booking our inflatable space vacations anytime soon?
Well, space tourism is definitely getting closer, but what's really cool about this technology is that it goes way beyond vacations.
Okay, how so?
Think about it. These inflatable habitats, they're strong, they're light, they're easy to set up. Now imagine using those same ideas for things like emergency shelters here on Earth, after natural disasters, or maybe even portable medical units that you could drop into remote areas.
Wow, I hadn't even thought about that. That's actually really smart.
Right. The same things that make these habitats work in space, being easy to move and super tough, could be game changers here on Earth, too.
It makes a lot of sense. So we're not just talking about escaping Earth. We're talking about learning from space and bringing those lessons back home with us.
Exactly. It's about using what we learn out there to solve problems down here.
That's a really important point. So often, exploration, even when it takes us far beyond Earth, leads us back to solutions that can help us right here at home.
Couldn't have said it better myself.
And there you have it. We've covered a lot of ground today, from those first experimental balloons to the possibility of these huge inflatable bases on the moon. It's clear that inflatable habitats aren't just some sci-fi fantasy anymore. They're a real testament to human ingenuity and our drive to push the limits of what's possible.
And it's only just the beginning. There's so much more to come.
Absolutely. So the next time you're struggling to blow up an air mattress, take a second to think about the amazing things engineers are doing with inflatable structures in space. Who knows, maybe one day those same innovations will change the way we live and explore right here on Earth. And for all of you listening, we'll leave you with this. If you could build your own inflatable habitat, what would it be? a space observatory to study the stars, a lunar research lab completely self-sufficient, or maybe even one of those zero-gravity concert halls we talked about. Let your imagination run wild, because when it comes to inflatable space habitats, the sky's the limit. Until next time, keep looking up and keep asking questions.